Hello everyone, and today we'll be doing class 8 physics. The topic is heat transfer, and then we'll continue with what we have been studying last week. So last week we discussed about linear expansion. We discussed about thermal expansion of solids, and then we discussed how the solids expand, though the expansion is not seen, but there is an experiment. We discussed that experiment here as well to show that solids also expand, the ball and the ring experiment. And then we discussed about the three different types of expansion: linear expansion, cubical expansion, and superficial expansion. So in the last class we discussed about linear expansion. What does linear expansion means? Linear expansion means the increase in length. Okay, when the solid expands in length, we say it to be linear expansion. And linear expansion depends upon three factors, and they are: first, the original length, then the material, and the temperature. So these are the three factors in which the linear expansion depends upon. Now, we'll continue from there only. So, as we are discussing about linear expansion, you have in your book a bimetallic strip. You know what is a bimetallic strip? A bimetallic strip means when two metals are joined together to make one strip. Okay, when two different metals are joined together to make one strip. And this concept of bimetallic strip is used in a thermostat. Okay, and what is a thermostat? Thermostat is a device. A thermostat is a device that is used for turning on and off the gadgets. For example, its thermostats are in fridge to control the temperature. Okay, so the concept of bimetallic strip is used in thermostats, which is used in thermostat. And even I told you bimetallic strip is used in electric bell as well, and electric bell is also an electrical gadget. The second one do you know over here is, see, the length of the rod does not depend upon whether the solid is a hollow or a solid. Okay, whether it's a hollow means something which has hole inside, like a pipe. Okay, like a pipe it's not completely covered, you have hole inside, and that's your hollow. And solid means something like that, which is completely covered, like a rod. Okay, so the length, when you increase the length of a hollow or a solid, it doesn't change if the temperature and the length of the rod if the length of the solid is same. If the object that you have used to heat, if you have used two different objects, one hollow and the other one is solid, okay, and if you supply the same amount of heat to both the solids, then the increase in length will be same for both of them, despite being hollow and solid. So it doesn't matter whether it's hollow or solid, as long as the length would be the same and the amount of heat supplied is also the same. Okay, that is what do you know here refers to. Now another one is the mathematical expression. Okay, the mathematical expression to find the linear expansion. Okay, and for the mathematical expression, what do we have? Say L0 is the length of the rod at the temperature 0 degree Celsius. So say there is a rod, okay, whose length is L0. Its original length is L0. Then what do? Is you heat this. And when the temperature rises, what happens to the length of the rod? The length of the rod increases. And the new length, let the new length be LT. Okay, T stands for temperature. So LT, okay, after heating, let L0 be the, okay, I'm writing it again. I'm writing it properly. Let L0 be the length of a solid at the temperature (0°C). Okay, at the temperature 0°C. After heating the rod for some time, okay, after heating the rod for some time, say at the temperature, that means you heat it till the temperature reaches T°C. Therefore, new length of the rod will increase. As I said, the length of the rod increases after getting heated. The new length of the rod will be LT. Okay. Now, the expression to find linear expansion, how much did it expand? Will be LT minus L0. So LT means increase in length minus original length. Okay, increase in length minus original length will give you L0 alpha T. What is L0 here? This is your original length. Now this term, see here, T stands for temperature. What does this mean? This is a Greek symbol called alpha, which you have been very much aware. This alpha is used as symbol for many other quantities. So alpha here represents linear expansion coefficient. Okay, this alpha here in this particular expression represents coefficient of linear expansion. Okay, it represents coefficient of linear expansion. So what does alpha represent here? Alpha represents coefficient of linear expansion. Okay, alpha is a Greek symbol. So what is the coefficient of linear expansion? It is alpha. This is for linear expansion of solids. So when solid increases in length, and by how much length does it increase? This is the expression LT minus L0, which is equal to L0 alpha T. Okay, L0 is your original length, T is the temperature, and alpha is your coefficient of linear expansion. And its unit is per degree Celsius. What is the unit? So unit of alpha is degree Celsius. It is per degree Celsius. Okay. What is the unit of alpha? It is per degree Celsius. And the value of coefficient in expansion of some metal is given there. Aluminium 24 into 10 to the power minus 6 per degree Celsius. Now 24 into 10 to the power minus 6 per degree Celsius is the linear coefficient of aluminium. Okay. Brass, it's 19 into 10 to the power minus 6 per degree Celsius. Again, it is the linear coefficient of, which means there is an alpha for brass. Now there is a note over here. Certain alloys are made so that which does not expand on heating. For example, invar. This is, those pendulum clock, the pendulum clock, the metal that is used in a pendulum clock. Okay, the length that you see, the bob that you see over there, the metal that you see in a pendulum clock which swings to and fro is actually made up of invar. Okay, it's an alloy. And another one is Pyrex glass. Nowadays you must have seen that most of the glasses, despite pouring hot water, they don't burst, isn't it? Generally they are made up of Pyrex glasses, which are a very good quality glass which does not expand easily, and thus the glass does not break even when hot water is poured into it. Okay. The next one that we're going to discuss is superficial expansion in solids. So I hope you understood what is linear expansion. So linear expansion means the increase in length. When a solid is heated, and if the solid increases in length, then we call it linear expansion. And the coefficient of linear expansion is represented by the symbol alpha. Now another one is superficial expansion. Superficial expansion in solids. Now superficial expansion in solids means when the solids expand both in length and breadth. So when you heat a solid, say you heat any solid, and if the length and the breadth both increases, then we say it has superficially expanded, which means its area has increased. Okay, it means its area has increased. So increase in area is denoted by the increase in length as well as breadth. Okay. So superficial expansion of solid. When a metal plate is heated in length, its length and breadth both increase. This increases the area of the plate. So what does superficial expansion means? Superficial expansion means increase in area, which means that is length and breadth. That means both length and breadth increases. Not only length, not only breadth, but both length and breadth increases. If both length and breadth increases for a solid, then we say it to be superficial expansion. And if only the length increases, then we call it linear expansion. The superficial expansion also depends upon three factors. The first one, original area. Okay, like the first one, like for the superficial expansion, the first factor was original length. Here it's original area. Now what does original area means? Say we take two different substances, okay, and one, you can see that, say this is a metal plate and this is another metal plate. This is your metal plate A, this is your metal plate B. Now from the figure itself we can make out which one has bigger, which one has more area. Obviously B, because its length and breadth are more. And here A has lesser length and lesser breadth, thus the area for A is lesser compared to B. So you can see from the figure itself. Now what you need to do is you need to supply the same amount of heat. Okay, you need to supply the same amount of heat. When you supply the same amount of heat for the same period of time, okay, you supply the same amount of heat for the same period of time, what will happen? Both the metal plates will increase in area, that means both length and breadth increases, but which one will increase more than the other? It will be B. Okay, so the area of B will be more than the area of A. Why does it happen? Because the original area of B is already more than the original area of A. So despite supplying the same amount of heat, it's obvious that B will have more expansion compared to A. Okay, that is your original area. So here in the book it's given the initial area of the plate. Larger the initial area of the plate, more is the increase in its area on heating. The second factor that it depends upon is temperature. Okay, the second factor that it depends upon is temperature. Now, temperature is also the same thing. Say you take two metal plates, okay, and this time the area of both the metal plates are same. You have taken two A and B. Okay, you have taken two metal plates, and you can see that they are same. So A and B have the same area. Okay. What do they have? They have same area. Their initial area is same. Now you supply A with less heat and you supply B with more heat. Okay, if you supply A with less heat and if you supply B with more heat, then which one will expand more in area? Obviously B. Okay, so what does it indicate here? More the temperature, more will be the area, more will be the expansion in area. That means B will have more temperature in this case, thus B will have more expansion. And A has less temperature compared to B, thus A will expand less. Okay, so this is what the second factor means, the increase in temperature. More is the rise in temperature, more will be the increasing area of plate. And how does temperature rise? When you supply more amount of heat. This is your second factor. Now, the third factor is material again. Material of the solid. Okay, material of the solid. So different materials they expand at different temperature or with different amount of heat. For example, if you take a cup of plate, and you take an iron plate. They have same area and you supply them with the same amount of heat. Okay, so you supply them with same amount of heat. Now, which one will expand more? Obviously, copper, because copper is better conductor than iron. Okay, so copper is a very good conductor, so it's a better conductor than iron. Thus, if they have the same area and same amount of heat has been supplied, despite that, copper will expand more compared to iron. Because they are different materials. That's what the material of the solid. The different materials for the same area and for the same amount of heat, they expand different because of their conducting property. Okay, how well they conduct the heat. So these are the three factors in which the superficial expansion of solid depends upon. Okay. And just like linear expansion, even superficial expansion has a mathematical expression. And how is the coefficient of superficial expansion denoted with? For the mathematical expression, let A represents area, A0 be the area of a plate at temperature 0 degrees Celsius. At temperature 0 degrees degree Celsius. So after heating, you supply it with heat for a certain time. So after heating, the temperature rises to T degree Celsius. So when temperature rises, the increase in area, therefore area also increases. So new area of the metal plate, let it be AT. So T is your increasing temperature. So how is the coefficient, or what is the difference between the area given? That is the how much increase in area has been. Okay, AT is your final area minus A0, A0 is your initial area. That will give you A0 beta T. Now A0, as you know, A0 is your original area, that is your initial area of the plate. T is your temperature, that is increase in temperature, beta. Okay, this is the term called beta, okay, not beta. Beta, it's a Greek symbol again, and this here in this particular mathematical expression represents coefficient of superficial expansion. Coefficient of superficial expansion. Okay, so like for what was the coefficient for linear expansion? Alpha. So alpha represented the coefficient of linear expansion, and beta represented the coefficient of superficial expansion. So then we have, so beta will be different for different materials. Then we have cubical expansion of solids, and I'll continue this cubical expansion of solids in the next class. Okay. Till then, have a good time, and if you have any doubt, please ask questions. Thank you.